We're asked to find the minimum and maximum values for a function y is equal to x to the fourth minus x squared on the interval -1 to infinity. So what we're going to do is first we're going to take a look at the derivative of x. Okay, so the derivative of f of x, I should say the derivative of y, so y prime, or we can write it as dy dx. That's equal to 4x to the third minus 2x. Now the question is, when is dy dx equal to 0? So when might this guy be at a minimum or a maximum? So in other words, we're asking, what are the critical values, the critical points? Okay, so to do that, we take this guy right here, set it equal to 0, so 4x to the third minus 2x. And now what I'm going to do is I'm going to factor out the GCF, so that's going to be 2x times 2x squared minus 1. And now what I'm going to do is set each of these guys equal to 0. So I've got 2x is 0, so I'm using the zero product property. Now I'll solve, so this gives me x should be 0. This gives me x squared should be equal to 1/2, or x is equal to plus or minus the square root of 1/2. So now I'm looking from -1 to infinity. So the question is, which one of these guys fall from -1 to infinity? Well, the square root of 1/2 is about 0.707 or 0.71. So that's going to fall on this interval. So if I take a look at the interval, here's -1. Right here is negative square root of 1/2. Right here is 0. And right here is positive square root of 1/2. Those are all the possibilities for our critical values. Now we need to test the endpoints of our interval. Well, we can't test infinity because it's not an actual value, it's not a number. The only one that we can test is -1. So these four guys right here are the guys that we're going to test for mins and maxes. Okay. So now let's go ahead and we'll work through that. So what we want is, what is the function at each one of these? So what is the function at -1? What is the function at negative square root of 1/2? What is the function value at square root of 1/2? Oops, I forgot 0. And what is the function value at 0? So when we plug these guys in, at -1, -1 goes into the original function, and so I'll get 1. Let's see here. If I plug it in, I get 1 minus 1, which is 0. Okay. Then, if I go ahead and I plug in negative square root of 1/2, that'll be negative square root of 1/2 to the 4th power, okay, which is a half times a half, or a fourth, minus a half, so -1/4. Okay, then again over here, we'll go ahead and do that, and we're going to get the same value. And if I plug in 0, I clearly get 0 out. So it looks like it's a situation where I've got two minimums, okay, and we'll look at these guys and say, well, maybe they're two maxes. Now, but here's where we have to be careful, okay, because this guy is not a closed interval. It doesn't guarantee that these guys right here are minimums and maximums. So what I'm going to do is I'm going to sketch out the graph for you, just to help you out a little bit. So don't always just look at a mechanical way of doing things. Try to take a look at all the pieces and what's going on. Now, if we had had a closed interval, we'd be good. But this is an open interval. So we can test like this, but we really need to know what else is going on with the function. So x to the 4th minus x squared. So let's graph that guy out. X to the fourth minus x squared. Well, this guy right here factors and do x squared times x squared minus 1, which tells me that it has zeros when I plug in 0, okay, for the x value, and when I plug in, let's see here, when we solve this, when we plug in 1 and negative 1. So at 1, we have a 0, and at negative 1, we also have a 0. So what that means is the original function, here's negative 1, here's 1, of course this is 0. It has zeros here, here, and here. Okay. It also has critical values at these points right here. Okay, so let's go ahead and plot those guys. Well, negative right here would be negative square root of a half, and right here would be square root of 1/2, 0.707, just like that. Okay. Now, we know the end behavior of the function. The limit of this function as we go towards infinity will increase without bound. So I don't have to worry about the negative piece because we are not looking to the left of this. Because of our interval, we're only looking from -1 to infinity. So I know the function heads up like this without bound because we've got a fourth power here. Okay, so the end behavior of the function, you can think about this in terms of taking the limit as x goes to infinity. It'll just increase without bound. Since we have this piece right here, and we know that it goes up forever, we know that the maximum value does not exist. We also know that if I take square root of 1/2 and plug into the original function, I'm down at -1/4, so we'll call this -1/4. So we know that this guy is down here. We also know that if I plug in -1/2, I get that same guy back out, like that. And we know that this guy's already at 0, so this must come down, come back up, come down, come back up. We can test for concavity if we want to take the second derivative. We already have enough information, but I'm just want to go through this. If I take the second derivative, so here's the first derivative, take the second derivative, I get 12x squared minus 2. Question is, when is this guy equal to 0? That'll show me changes in concavity. Okay, so where do we change concavity? Well, this right here, to solve this, will give me x squared is equal to 1/6, so x is equal to plus or minus the square root of 1/6. So somewhere right in here, roughly, we change concavity, and somewhere right in here, roughly, we change concavity. Concave up, to concave down, back to concave up. Also, we can take a look for points of inflection if we want to, or we can take a look to see if these mins and maxes are actually local minimums and maximums, and they are. Okay, so what we have is we have a max not existing, and we have a minimum does exist at x equals negative square root of 1/2 and positive square root of 1/2. And so those will give us our minimum values. And of course, we don't have a maximum value. We do have some local maxes here and here. Okay, so those are two local maxes, but we do not have any global maxes.